Okay, these notes are for section 5.5. We are going to be going back to limits just briefly. It's kind of an odd place where we are right now. I know that we've been talking about applications of derivatives in this chapter, and we're going to come back to that. But this is sort of an aside. So we're going to go back to doing limits. And what we're going to be talking about, for example, in this first example, is what is the limit as x goes to infinity of a function. And in this first example, we're going to do the function 3x plus 1 divided by x minus 4. Okay, and so the first way we're going to investigate this is just through a table of numbers, which we've done before. And so I've given a table for you, and I want you to use the x values 10, 100, 1,000, 10,000, and 100,000. And I would like for you to plug these x values into this function f of x and then record the values in the table. You might want to pause the video and go ahead and do that now. You're going to notice a pattern in the y values. The y values are going to approach one specific number, one specific output y value. Okay, and now here I have graphed our function in question. I have a picture of the graph of the function in question, 3x plus 1 over x minus 4. And what I want you to do is I want you to notice the horizontal asymptote. There's a horizontal asymptote that's happening probably right about here. And what is the equation of this horizontal asymptote? Well, it's y equals 3. So y equals 3 is a horizontal asymptote, and that's no coincidence from the answer that you got up here in the table. This answer is supposed to be 3, and you should have seen that based on the pattern of what your y values were when you input these x values I've specified here. You should have gotten really, really close to 3. Your calculator might have even given you the number 3 a few times. So because of what we just talked about, we have a new definition of a horizontal asymptote. The line y equals L, is a horizontal asymptote if your limit as x goes to infinity is L. In the last case, it was 3. But also, you could have done the limit as x goes to negative infinity and gotten that same answer, and you would have a horizontal asymptote there. So we have a connection between horizontal asymptotes and limits as x goes to infinity. That's not a shock because I don't know if you remember that when we did limits before, if you did the limit as x goes to a, as some number a, and you got infinity as your answer. So for example, the limit as x goes to 2 from the right of 1 over x minus 2, that has an answer of positive infinity. This meant that we had a vertical asymptote at x equals 2. And so when you have infinity involved in limits, that's what asymptotes are. Vertical asymptotes are when the answer is infinity, and horizontal asymptotes are when x goes to infinity. Okay, so now I'm going to talk about how we compute limits analytically. You're going to have a function, not a graph. We're not going to do a table. We're not going to have a calculator and type in 10 and 1,000 and 10,000. Instead, how can I do this like algebraically? Well, we're going to use this theorem here. The theorem says that if you have a positive rational, if you have some constant and you divide by x to any power, and x goes to infinity. So for example, let's think about an example of this. Maybe the limit as x goes to infinity of, I don't know, I'm going to pick a big constant. I'm going to pick the constant 10,000. And then I'm going to divide that by, I don't know, x squared. So what's going to happen if you think about what a table of values would be for this limit? What's going to happen is that x is going to get really big. You can plug in as big a number as you want for x. And then you're going to square that number. So you're going to multiply it by itself. So you're going to get a super gigantic, ginormous, huge number on the bottom. And even though I have a big number on top, 10,000, it's not going to compare to the bottom. So when you take 10,000 and you divide that by, I don't know, something on the order of 10 to the, I don't know, this number, whatever that number is, you get 0. The answer to that limit is 0. No matter what, you take a constant number and you divide by infinity, you get 0. So this is the same idea as what is 10,000 divided by infinity. Yes, 10,000 is big, but infinity is not even in the same ballpark as infinity. And so when you divide that by infinity, you get 0. Or 3 divided by infinity. Anything divided by infinity is 0. I shouldn't say anything divided by infinity is 0. Infinity divided by infinity is what's called indeterminate. We don't know what that is. There's a quote in a John Green book that says, in which the guy says, some infinities are larger than others. And that's actually true mathematically. John Green is an author, but he's also a mathematician. And so he has some really interesting math things in his books. But anyhow, so infinity divided by infinity is indeterminate. Sometimes the answer to this is infinity. Sometimes the answer to this is e. It's all sorts of like random things. So we don't know what it is. It's not the same thing as non-existent. We don't. This might exist. We just can't determine what that number is, if it is a number. Okay, and so now practically we're going to do 4 examples and then we'll be finished. All right, so my first example analytically, I have, notice these are all rational functions because we're talking about horizontal asymptotes, and those are in rational functions. So we're going to do the limit as x goes to infinity of this rational function, and there's a trick that you do. And in order to do the trick, the trick is going to use the theorem. And so in order to use the theorem, I have to have a number divided by an x. And so that's what we do. I'm going to go over here to this page, and I'm going to divide all the numbers on top by x to the third. I'm also going to do that on the bottom. When you employ this trick, notice I'm not changing my question. When you multiply by 1 over x to the third over 1 over x to the third, that is a very complicated way of saying the number 1, because they cancel. And when you multiply by that, you're going to get fractions inside your numerator. This is not something we usually do, but it's going to help when you're doing this infinite limit. When you distribute this 1 over x cubed into the numerator, you're going to get 1 plus 2 over x squared plus 1 over x to the third. And then in the denominator, when you distribute your 1 over x to the third in, we're going to get 3 minus 1 over x squared plus 2 over x cubed. And now I can use that theorem, and I'm just going to do the limit piece by piece. So the theorem, well, this is just the number 1. And so I have the 1 from that limit because there's no x. X is going to infinity, but this is still the number 1. And then in the next piece, I'm going to use that theorem. As x goes to infinity, 2 divided by infinity, that is nothing. That's 0. And then at the end, I also have plus 0. And this is going to be divided by 3 minus 0 plus 0. And so this is the number 1/3, and that is your answer. Okay, so Mrs. Griffith, where did you decide to employ, like, how did you know to use 1 over x to the third? How did I know to do that? Well, you're going to do 1 over x to the r, where r is the biggest exponent. It's the overall, so if you look at the degree of the numerator and the degree of the denominator, you take the bigger one if one is bigger than the other, and that's the one you use. So let's look at this second example here. Let me call this one number 2. I'll do 2 in blue. Here, I would divide I'm going to do the trick again where I multiply by 1 over something in the numerator and the denominator. What should I multiply by? 1 over what? Well, look at the degree of the numerator. The highest number is 2. And the degree of the denominator, the highest number is 2. Which one's bigger, 2 or 2? Oh, they're the same. So we're going to divide by x squared. And now you simplify that. And so you get 2 over x squared minus 3 divided by 5 plus 4 over x. And now we're going to use that little theorem that says that if you're doing the limit as x goes to infinity and you have a number, plain old number, divided by any power of x, then that is going to be 0. So you get 0 minus 3 over 5 plus 0. This answer is negative 3/5. Negative 3/5. Moving on, I have 2 more examples. And I'm going to do both of these for you. Okay, let's talk about what to multiply by here. I'm employing the trick on all of these. 1 over x to a power, 1 over x to a power. In the numerator, the highest number is 2, and in the denominator, the highest number is 3. So you don't want to do, you want to pick whichever one is the highest. So the highest, biggest number is 3. So I divide by 1 over x cubed in the numerator and the denominator. And so now my limit is the limit. Notice this is as x goes to negative infinity. That doesn't make a difference. You still do the same techniques, whether x is approaching infinity or negative infinity. All right, so this is going to give us, when I divide x squared by x to the third, I get 1 over x. And then I get 2 over x to the third. So that's my numerator. And this is going to be divided by 1 minus 1 over x to the third. So now I'm going to use that theorem, 1 divided by infinity. I'm going to show you another way of sort of evaluating this. You could think about 1 divided, or you can think about plugging in infinity. We're not really plugging in infinity. That's not a number. You can't plug in something that's not a number. But you can think about the idea of what that would mean. So if I take 1 and I divide it by infinity, that should be 0. And 2 divided by infinity, that should be 0 also. 1 is still the number 1, and then 1 divided by infinity is 0. So I get 0 in the top and 1 in the denominator. And what is 0 divided by 1? 0. So my answer is 0 here. Last example. This is very similar to the other example, except I've switched and made the x to the third now in the top instead of the bottom. But notice 3 is my highest exponent. So I'm going to do my trick, multiply by 1 over x cubed over 1 over x cubed. I'm going to do the limit as x. This is, again, negative infinity, but that doesn't matter. And so I get 1 plus 2 over x to the third over 1 over x minus 1 over x to the third. I evaluate this at infinity. This is 1 plus 2 divided by infinity over 1 divided by infinity minus 1 divided by infinity. Because infinity to the third is still infinity. And so you get 1 plus 0 divided by 0 minus 0. So now I get the reverse. Instead of 0 divided by 1, I get 1 divided by 0. And we all know that you may not divide by 0. If you take 1, you divide it by 0, you actually get infinity. And we should worry about the sign here, except that 1 is positive. So that's the only sign you have to worry about. 0 doesn't have a sign. So that's nice. You don't have to worry about that. This might be 1 minus 0, but who cares? 1 minus 0, 1 plus 0, the answer is still the same. It's 1. And so the answer there is infinity. All right. That is all for today's lecture, and have a good night.